start with introductions. Brandon?
I'm Brandon Weiss, Weiss Building Development, home builder, remodeler. Chicagoland area, focusing solely on sustainable construction, so this is a perfect fit for us. Really excited to be a part of this project. I'm a graduate master builder through the National Association of Home Builders, lead AP through the USGBC, and also a master certified green professional through NHB. So, you know, we got a lot of designations, done a lot of spent a lot of time on continuing education, things like that. So, a project like this was a great fit for us, and real excited about being a part of it.
I'm Eric Barton, built more insulated concrete. Brandon and I have a similar path. I'm a graduate master builder as well and certified and AP. Tom and I are certified passive house consultants. We met each other in training. My company does insulated concrete forms and super insulated structures. So insulated concrete forms and what else was I going to say? I don't know. Yeah, it's been a long day. So that's it.
Okay. Barry, you want to say a few words?
Hi, I'm Barry Stevens from Zender America, and we will be talking more about the heat recovery ventilation system here. Zender is a Swiss company. We are distributing the Comfo Systems heat recovery, energy recovery ventilation systems, and you see that some of the ducting and so forth. We'll go through that. And I've got a couple of other guys here with me from our company.
All right. Kevin, you want to introduce yourself here since you're the local rep? Thanks.
I'm Kevin Rapp. I'm also with Zender. I'm the Midwest representative. So we've got a whole team out here because we've got such a strong showing out here. We're excited to see that there's a lot of people behind the progressive building, and we want to be here to help.
Thanks. All right, I'm going to clip this on so I can gesticulate. But it's funny because, okay, this will work, right? All right, good. So there's cards up here and brochures if you want to contact anybody afterwards. I'm sure everybody would be happy to do that. So I imagine most people here are familiar in general with passive house principles. Hopefully some of you have come to the previous presentations we've done on the house. I think in, I want to say July? No. June, maybe? We presented about the design concept and everything, but in a nutshell, not to spend too much time on the passive house basics, we're designing a really, really low energy building, and we're doing that by super insulating it and making the thermal shell airtight as we can. So it was an interesting project for me. I had finished training and had done a almost passive house and was really hoping to get a project. And in training, Eric and I were talking about ICFs and this kind of thing. And in the back of my mind, I was thinking, you know, that could be a really nice fit because ICFs, insulated concrete forms, are inherently airtight, this concrete wall. So then it just so happened that this client called me up and said, hey, we saw that you did this. We want a passive house, but we want it to be concrete. Can you do that? It's like, yeah, actually, I think I can. Or I think we can. So it was a great thing that then we met with Brandon and Eric and put this team together. So Eric is the thermal shell. He's basically responsible for everything that has to do with insulation and airtightness. And we're right in the kind of tail end of that, and we're getting ready for finishes. Just to tell you a little bit about the components here, the ICF walls obviously are a key component. We have a wood air barrier on the ceiling, which will show you a lot of fiberglass insulation above that in the attic. Concrete slab on the bottom of this thermal shell, which has 8 inches of EPS foam insulation underneath it. And then we have these windows. So these windows are by a company called Zola, which is a relatively new company in Poland, started by a German architect who trained in Switzerland and lives in Colorado now. So he's a real, like, you know, global guy, Florian Speyer. We priced out a number of windows on this project, and there's a big range in cost. And basically what we found was that there are a lot of PVC windows. Hey, Jason, would you do me a favor in grabbing that window corner sample right there and bring it to me? We found that basically in this climate where it gets good and cold for a long time, we want to have a super high-performing window, and we need a triple pane window, a double low E, argon filled, And so this kind of glass setup is what we need. There are a few options in North America, but most of them are fiberglass. I mean, made in North America. Most of them are fiberglass. Most are made in Canada. Thermotech, Fibertech, Sirius. There's a couple of options. But there's a lot that's coming out of Europe, and all of a sudden there's just a whole slew of windows that are starting to hit the U.S. market and get more in our hands. Is Murat still here? Yeah. So Murat is a guy who's a member of our group. He reps Unilux. Sorry, I was going to say, yeah, one of your competitors. And they have a product like this. This is Zola's UPVC. So this is a PVC window, which is really cost effective and super high performance, because this is really where most of the performance comes from, right here in this glass. High solar heat gain coefficient, so you get a lot of thermal help in the wintertime. Very low U value. I mean, these are like R8 or 9 by NFRC standards. R9. So, so it's a super high performing window. We didn't want to go UPVC. We had enough of budget that we could afford a wood window, and so we wound up with the Zola. Just to show you a little bit about how these tilt-turn windows work, because it's not that common in the U.S. They're open in, and you notice that they have these like triple-stepped seals. Thank you. I'm just going to struggle with words today, so help is appreciated. So here are these 3 compressible seals that give this a great air tightness. They just installed another project, did the blower door on it, and got one of the lowest ratings that this house came out to. Not this house, the one that Zola just installed was a 0.18 at ACH 50, so it's super airtight. So a big part of that are all the penetrations, right? So anyway, this is the casement function, open in, and then you can go like this and just get a little bit of ventilation like that, and it doesn't sweep everything off that you've accumulated on the sill if you're like me. So anyway, this is obviously just a temporary hardware. There's a really nice German roto hardware that goes with this, but we're not going to install that until the very end. Not that I know of, no. All these are being made in Europe. So they had to come over on a container, which is something to know. When you do this, you have to make room on the site for a container and pay for the container to be there, or you have to unpack the whole darn thing. And these things are like furniture. And, you know, if you break the glass, well, it's going to be however many weeks to get the next one in. So, so there's some things to think about if you're going to be bringing windows over from Europe. But your rep will walk you through that. So anyhow, so the windows are a key component. The ventilation system is a key component. We'll talk about that later. And then the mechanical systems for this house, again, because it's super low energy, it takes very little to heat and cool. That's point number 1. Point number 2 is the temperature changes in a super insulated building really slowly. So you don't have to worry about, you know, the living room is 70 degrees, but that bedroom is like 58. That doesn't happen. You're just not losing enough heat. So it tends to be very even through the house. And therefore, you don't need to have a ducted system in a fairly compact building like this. So you don't need to duct your heating and cooling. So we have 2 point source units. And they're supplied by Mitsubishi. They're little, what they're called mini split heat pumps. And if any of you are here for that presentation, Mark Kuntz from Mitsubishi Electric came and gave a really nice presentation about how they work. But that black line set with the copper sticking out over the window is where one wall unit goes. So there's a little compressor that sits out in the north side yard, and then the wall unit sits there, and it's about, you know, yay big, and it just will blow a little bit of heat in a recirculating system, or a little bit of cooling as required. There's another one upstairs in the master bedroom. So, so the conventional heating system is not required in a passive house. So those are the key components. Design-wise, the things that I had to figure out that was unusual for me as a U.S. trained architect is how to design a thermally bridge-free building and how to design an airtight building. And so those are the main details we want to point out as we kind of walk through here. But basically, what they tell you in passive house training is that you should be able to put your pen down on the the perimeter of the building, section view, and draw a continuous airtight line that describes exactly where your air tightness is going to, how it's going to be achieved. So here, it's basically the concrete walls that meet up with the plywood that we attach to the underside of the trusses, the wood trusses on the ceiling, the second floor, the roof trusses. And then we drop the ceiling below that, so we're not penetrating all through our airtight layer. You cannot penetrate the airtight layer. And then on the basement, we have a plastic sheet under the slab, which is a very heavy, it's called Stego wrap, and that comes up on the inside. We taped it off to the ICFs. So, what's that? How many mil? 500. Yeah. It's a really thick. You'll see it down there. And then, of course, every penetration in that airtight layer has to be really rigorously studied. And I don't know how many conversations we've had about the windows, but as you look at some of the windows, some are almost airtight so far, and some aren't. So those ones over there where you see the foam are not yet. They don't have the airtight layer. These here where you see the white tape around, this is Siga tape. Siga is a brand that most people who are doing passive houses are using in one way or another. They have a lot of products that are made for very specific situations. I mean, this is a pre-bent 2 peel-away strip, fits into a corner type tape for interior sealing of windows. And then they have this green stuff here. You know, they have tapes that breathe, tapes that don't breathe. And so it's a really important part of an airtight house. You always wind up with a lot of tapes because they last. And so, tell you what, why don't we start walking? Do you guys want to, well, why don't we take, before we go, say a little more about the air quality aspects, okay, and the ICF kind of specifics maybe? Okay. Okay, yeah. Here we go. Thanks.
So beyond the passive house certification that we're going for in this house, which really focuses on the energy efficiency, sure has a lot to do with the air quality with the Zender system and things, but actually sourcing the materials and looking into, doing a lot of research on what plywood is used, making sure we have, no plywood that we're using has, it's all exterior grade, so it has no urea, formaldehyde in it, making sure the glues and resins in it also are healthy. So we're looking at a healthy house certification. It's going to be a pilot project for them. And basically we have to turn in every material used, be it glues, adhesives, plywood, anything in the home has to be tested by them by third party, making sure that it passes their standards. And also, when the house is done, besides doing the energy testing, we're also going to be doing testing on SVOCs, TVOCs, formaldehyde, and any kind of dust particulates, something like that. So we're really doing a ultra efficient but ultra healthy home and trying to combine those two to give a really high quality, well performing home. Nothing that's been done, at least that I know of in this area. So very exciting to kind of combine those two things. And essentially that's what green is all about, is combining health, energy efficiency, and then sustainable materials. And, we've used some advanced framing details here, our corner details, and 2 foot on center, and doing that kind of stuff too. So also doing things environmentally responsible as well. Eric, you want to take over the ICF?
Sure. So on this house, and we have the insulated concrete forms running from the footing all the way up to the roof trusses, okay? So what we achieve with that with ICFs is you have a continuous 2 layers of insulation on the inside and the outside that is unbroken except for wherever we have a penetration for mechanical or electrical or a window. And the windows are always the weakest element of any type of a wall system. So, with our Gorilla Buck system, which you really can't see much anymore, there is the concrete is not touching the plywood, so the only thermal bridge we have in this entire wall is the wrap around the window, so a window opening. The other thing that you're going to see, which is different, so when you take an ICF building from the footing all the way up to the roof, different than typical lumber frame construction, when you go up the stairs, you can see that our insulation plane on the inside is continuous and unbroken. Okay, and we achieved that with setting the open web trusses on a brick ledge. Okay, so in typical wood frame construction, when you take your rafter members out and you do platform framing and you take your rim joists all the way outside, you have the ability to make that floor, that subfloor cold, because you're taking that subfloor element all the way to the exterior. With this, with the ICFs in this particular detail, it's completely inside the shell. So that keeps this floor a lot warmer than any other typical type of construction. You'll also see when we get upstairs, we'll talk a little bit about the airtight ceiling detail and what we had to do there. But basically, you know, when you're running with the ICFs, the concrete, once you pour it, it really gives you a super airtight building, and that's one of the key components in passive houses. So any other additional questions we can answer as we head up and down the tour.
Yeah. Why don't we head downstairs? You know, watch your step on the stairs on the way down. We'll look at the basement. You can see the slab down there. You can see that. Yeah, okay. Start again here. Thanks. So we've got a 4-inch concrete slab, which you know, when we decided to frame this thing with these super strong walls, we realized there's no real good reason to put an interior load-bearing wall in here when we can span outside wall to outside wall. It makes the basement a lot simpler. There's no steel line or posts and beams. So we just have an unbroken 4-inch concrete slab here, sitting on 8 inches of Type 9 EPS, you know, styrofoam basically insulation, and then underneath that is the plastic that wraps up. So the plastic is our radon barrier, our soil gas barrier. It comes up the sidewall, and then we tape it off with the SIGA here to the face of the ICF. And it's really funny because, you know, when I'm drawing these things, I've got the building section I'm drawing. I'm looking at the plastic coming up and taping off to this styrofoam. I think, God, it looks really weak. You know, I want to take that plastic and all the way back to the concrete and lock it into the concrete. Well, we couldn't do that because the bottom ICF form needs to get leveled up on the footing, and you can't have a piece of plastic in there where you're trying to level it. So we decided to basically do it this way. And after looking at that, I thought, you know, there's not a lot of air moving around down there. So the worst case scenario would be there's a little bit of a gap where the tape and the EPS meet, but it's not like we've got a bunch of air blowing around down there. So we basically figured we're okay. We'll tape it off to the face of the EPS and should be fine for airtightness. Here you can see a pretty complete installation in terms of the airtight layer. You can see a little bit of light, I'm sorry, for the window. So this is a big Zola fixed window, 3x6. You can see a little bit of light coming in on the left side of that jamb right there. They're going to foam that with foam, low expansion foam insulation from the outside before the siding goes on. And that allows us to have a nice clean surface here. And we've been experimenting with these, and you can see a couple of windows where there's foam that was put on from the inside, but now we have to trim it back, and it's just kind of a mess. So this is the system we're going to wind up using. The metal clips that you can see on the jambs are what we use to attach the windows to the Gorilla Buck. The Gorilla Buck is a 3/4 inch plywood that has a backside. It's a patented thing that goes with ICF systems. It locks into the concrete, so it's not going anywhere. But it means that you only have 3/4 of an inch to attach your window to. So typically, you like on a typical American window, you have a nailing fin. You just nail it to your outside sheathing. Well, here we don't have that option. And the window installer said, well, I can give you two options. You can do a clip that screws into the side, the buck like this, or you can just screw through the jamb, through the jamb into your buck. Well, the screws he had were like this, and if you go just a little bit past the buck, you're into solid concrete. So that's not going to work. So we decided to use the clips, even though we're going to have to tape over those for our airtightness. So in other words, when you're looking right here, an accumulated set of gaps like that right there would blow our airtightness for this house. So we're taking this white tape. First of all, we're doing that, and then we're taking another piece of tape to cover these. So it's, you know, a lot of taping, but
Lots of
yeah.
Why are you taking the screws?
Because it's not the screws themselves, it's the fact that this break in plane right here creates a little tiny gap which can get air coming through. So we're going to cover that gap up by going around like that.
Second tape?
Yeah, it's all a SIGA. This is the Corvum, which is their interior air sealing tape. So, yeah. So the fact that we're clear spanning is why you're seeing these relatively deep trusses, but it allows us, as you can see, just to have real easy access for plumbing and electrical and all that.
What are the metal panels?
Those are gusset plates. It's just what holds it together. They just gang nail it, kaboom, you know. It's a quick thing. The orange, by the way, the orange pipes are the fire protection system. River Forest requires fire protection for new construction. It added about $8 grand to this house, I think. Is that right? More? 10 and a half? Okay, yeah. See, architects, 8 grand equals 10 and a half. Rule of thumb. That's what I tell my clients.
You've used the top core bearing?
Yeah. Yeah, pretty frequent with the you can do top chord or bottom chord bearing. Here, we wanted to use this brick ledge detail, and it seemed better for us to use the top chord bearing. Yeah, well, let's look at that detail a little bit. You can see it when we go upstairs to the second floor, but basically, if you look carefully here, you can see how the face of the form work. There's a special form that's a brick ledge, so it kind of swoops up like that. Well, normally you're using that on the outside just below grade to set your brick veneer. You don't need to make your whole foundation 12 inches thick or 4 inches thicker just to support the brick. So we looked at that and said, well, if we flip it around, we can set the trusses on that. And then we had to do a little study using our thermal bridge software, Therm, to figure out, okay, so the concrete in there is relatively cold in terms of the entire building envelope. Is that going to cool down our interior too much? We're going to get into potential condensation problems, etc. And so the detail we came up with that works is we're setting a 2x4, treated 2x4 plate, which is the bearing plate for these trusses, on top of a 3/8 inch thick closed cell polyurethane sill sealer. So that gives us a little bit of a break there. And then we're going to take spray foam and do 3 inches of foam around that whole thing. So basically encapsulating that. And then that basically protects and keeps the cold out of the house. Because remember, the concrete, in the middle of the winter, the concrete in here is going to be, we figured, roughly 40 degrees, I think was the number. Do you remember, Eric? Where's Eric? Okay. I think so, yeah.
So the transmission of the cold coming through a 2x4 is nullified by the insulation plus also the length of the 2x4.
Yeah, well, primarily it's the insulation around it. Yeah, exactly. So.
And that thermal in the gasket.
Yeah, and that gasket, right.
Yeah. Does it break down over time, that gasket?
Well, it'll be gone.
Well, ozone.
Wait, isn't your warranty a little longer than we? Yeah. No, the polyurethane, closed cell polyurethane is basically. Yeah, right. That's the problem if it's in a landfill.
It's inert once it's.
Yeah.
Once the styrene comes on, it's polymer.
Yeah, yeah.
Would you do anything for, say, like renewable? Like
You mean what can you use for a sill sealer? That's
no,
like a.
For renewable, say like your conduit for.
Yes. Yeah, it's solar PV ready. The state scrapped the PV rebates. They were ready to do a 3.5 kilowatt array for this house. Yeah, and so now it's not there. So we have a solar photovoltaic system for, solar thermal system for domestic hot water. Preheat out on the garage, and then it comes into a storage tank back there in the store. That's the basically utility room back there. Yeah.
One more question about the bearing system. Is there any thought given to making these interior bearing walls like structural walls and not sitting on the outside?
Yeah, we did do that at the stairway because the loads weren't too great. But remember, we wanted to keep this slab really simple, 4-inch slab. And if you clear span it, you've got a lot of load right here. And so that would have made us had to thicken the slab and get a more difficult detail, potential thermal bridge problems. As it is, it's just really simple. Just flat, put down the foam, put down the slab, up go the walls.
So your 8 inches hits the wall?
Yes.
Oh, yeah.
Yep.
Overlaps the footing, so there's that.
That's what I was wondering.
There's the disconnect, absolutely. That's one of the key details.
But I thought the same thing as him, because, if you did that, and then for this plane of insulation, you could do this as well. So I'm not quite exactly sure.
Well, there's a lot of ways to skin the passive house. And a lot of people are doing double wall construction where they'll do an interior 2x4 structural wall with the exterior face of that sheath with 1/2-inch plywood or OSB, which is the airtight layer, and then either a secondary stud out there or Larson trusses or TJIs, 12, 15 inches, whatever, to get all that insulation thickness. But then you get a simple stick frame, boom, 2x4 up. The only problem is you want to test your airtightness layer, but that means you're going to have to, if you want to weather in your house, you're going to have to build the other wall, get the Tyvek on it, et cetera, and so you've got a little more to deal with there. But there's a lot of ways to do it, and hopefully in the next year or so we'll start to get a catalog together through FAIS of Passive House Alliance US of sort of catalog of details that US builders are using. There's a great book from Europe, but they just build differently enough there that we can't really use a lot of those details. For instance, in Germany, the TJI company has, you can do TJI walls, studs. But here, they haven't been run through ICC, so the code officials need to see a book of calculations, of structural engineering calculations. So,
What would be the thermal break then?
well, then you would do a separate wall. So you do the TJI structural wall, you sheathe it on the inside, tape it, make it airtight, and then stand off a wall like this. So that's where you run all this stuff, and you've got that nice, clean, untouched, unplumbed, and unelectrical airtight layer. Yeah.
Even though all that mechanical is basically inside the envelope, if you were to make 3 inches of close-up foam, let's say, and encapsulate each one of that first unit stuff, the exterior part of it, and then have a gap and put all your mechanicals in there and fill it with 9 inches of cellulose, let's say, why wouldn't that be certainly more economical?
Well, let's talk after the meeting. I'm not quite picturing it, and we should probably circulate. But yeah, there's another way to skin it, I'm sure.
One quick thing, Tom, no
Yep.
HVAC down here, just the 2 units?
That's right.
Upstairs?
So this ventilation system is moving the air through the house constantly, right? It's exhausting from all the wet areas and supplying to the living areas. So we've got a couple yeah. Supply. Yeah, but one of the interesting things when you do the PHPP, the Passive House Planning Package energy calculations on the building, you can see where you're losing your heat, right? And our heat losses to the ground are pretty minimal, so which is intuitive, right? I mean, the temperature here isn't as bad as the temperature here when it's, middle of the winter. So we don't have as much to worry about here. So yeah, we're not doing that. And no radiant heat in the floor. It's a question a lot of people ask. If we were to put radiant heat in the floor and get it up warm enough that you could feel that it's warm, we'd overheat the house immediately. Because, your skin temperature is where, in the upper 80s or something like that. So you've got to have a warm floor, but we need so little heat in here that radiant heat doesn't really make sense with the loads that we have.
Whether you want to mention that you don't need to get the registry right because standard construction.
Yeah, well, that kind of goes with what I was saying earlier about the fact that we don't have a ducted conditioned air system. And the ventilation system is just making sure that fresh air is getting distributed to the house and exhausted from the areas where pollutants are made, basically the kitchen, bathroom, laundry, etc.
Is the floor really broken from the ICF?
It butts the foam.
Yeah, this is the thermal break.
Okay, so in other words, go right to the foam.
Right.
Yeah, yeah. Little expansion again, that's it. All right, why don't we head up to all the way up to the second floor. Watch your step. There's a couple uneven steps up there at the top, and then we'll...
You can see on the stairs, if you want to look at the brick ledge detail.
Yeah, on the second floor
You can
landing.
touch and feel.
Yeah.
I just thought, that's an interruption. Oh, yeah, this is an interruption in the foam. It's a small one.
Do you see what I manipulated? Do you want to grab it?
No.
What do you need this one? Oh, just my little handle for the...
Oh, maybe I am.
It's down by my bag. You ready? You good? Okay. So, a couple good questions on the way up here. One thing I just totally forgot to talk about was how the entire wall system is made up. So, there's the ICF system itself, which gets you about an R28. Eric up here yet? Yeah. Is that right? R28? But we needed about an R50. So, at first we thought, well, let's just fur out those walls to the inside and put a whole bunch of fiberglass or cellulose insulation. But while it would be fine to do an ICF wall and just put drywall on the inside if you needed an R28, for us to do that means that we're putting a lot of insulation between us and the ICFs, which means we're keeping those ICFs really cold. So if any air can get into there, it could hit a plane that could be a condensation plane. So we had to study this thing and figure out how much we could afford to put insulation on the inside, and therefore we had to put the rest of the insulation on the outside. So the sweet spot that we found was 2 inches of polyiso insulation on the outside of the ICFs. The siding goes on top of that on a rain screen application. And then we have these 2x4 walls stood off of the inside face of foam by 1/2 inch. So we have 4 inches, and we're using a blown-in batt fiberglass insulation system. So they basically, the studs get netted. You blow in the. Well, you explain it. You're the blown-in batt guy.
So the walls are netted, and we blow in the fiberglass insulation. It's a Green Guard certified fiberglass insulation, and with netting it, you don't have any worry about particulate in the air. So it's still a healthy product, and with the Green Guard, there's no formaldehyde or phenol added to the product that we use. So it's still very healthy. Basically, they overfill the cavity a little bit so it bows out, and when you push your drywall on, you're recompacting that and making sure there's no voids in the insulation. You have 6 points of contact, and nothing's ever going to settle with the fiberglass. It's not blown in wet, so nothing's drying out and has the opportunity to settle over time. So you're going to have that R value in that wall forever at that install.
What do they call that? Fence pad?
It's called bibs, blown in bats.
It's not like fence pad.
No.
Thanks. Yep. Okay, that was question 1. Question 2 was about these whips here. So you'll see in the house a number of places where we have these soffits framed like this. We're doing a lot of ambient lighting using indirect uplight out of these cokes. So there's going to be a piece of wood trim here that hides a T5 fluorescent linear fixture. T5s are really, really efficient, and of course we're looking not just for thermal efficiency, but also overall energy efficiency on the house. So we try to use those in a lot of places. You'll see that big one down in the living dining space, and then up here, and then in a couple of bedrooms. So this is just really easy stuff to frame soffits out of. This is our airtight layer, and it's almost watertight too. We had a nice big rainstorm the other day. And so basically all the seams of the plywood get taped. Ran out of tape, so there's a couple places of stuff to get hit. But this is typical passive house strategy. The real trick of this was how do we connect it to the concrete of the wall, our air barrier of the wall. So the deal there was I came up with something really good and difficult, and strong-armed Eric into doing it. So at the top of the ICF, there's a treated 2x laid in, which is the bearing plate for the roof trusses. And so before we set that thing in, we took this heavy plastic and laid it underneath where that was going to be. Okay, so that plastic goes out, it tapes to the outside face of the ICF form, and then it comes in continuously and tapes off to the air barrier of the ceiling. So that was our way to do that with kind of off-the-shelf stuff. And then the ceiling is just continuous. We got a couple penetrations, which take some serious gasketing. Any place there's a penetration, which is very carefully controlled by Brandon and Eric, gets one of these gaskets, and we still have to cut back these a little bit to fit them up perfectly. But there's a company called 475 Supply. Is that their official name? 475? High Performance Supply, yeah. And they've got gaskets. They've got they got a whole bunch of products that you can get sort of passive house type components from, and they're in New York. So yeah, that's basically the ceiling, and then we're putting 2 feet of that pink blown-in fiberglass in the attic for about an R100 on the ceiling plane. It's basically easy at that point. We just kind of filled it until we hit passive house certification. I mean, there's a lot of dials to turn, and yesterday there was a fascinating webinar. It was really great to see about how you can put what they call a dashboard onto this PHP software to be able to do things like tweak your assembly R values, sort of dial them up and down before you've sort of entered it all into the software. Well, this would take a long time to describe, so sorry about that. But anyway, the point is that it's a whole systems approach. So walls, ceilings, floor, it just all has to work together. Windows, amount of solar gain for, you know, wintertime heating, amount of shading for how much wintertime heating we're not getting, and for how much summer cooling we're going to have to spend. We've calculated everything down to the, you know, the watt, pretty much. So, what else up here? Anything?
So traditionally, you know, this house has 4 bathrooms, a half bathroom, 1 laundry room up here, 1 in the basement. That's future possibility of a laundry room. We were able to talk the plumber into doing only 2 vents for all his plumbing, which wasn't traditional for him. So you can see there's a lot of sideways and horizontal vent pipes. We were able to get all of our penetrations through 2 with our plumbing, and then we have our radon reduction system as a 3rd PVC through the roof. So really minimized our penetrations there. The only electric penetrations are 1 conduit for future solar PV, and the other one for an attic light, which we had to have by code, unfortunately. But no one's going to go up and play in 2 feet of insulation.
Oh yeah.
Because these holes are inside the envelope, there's no stack effect,
Yep.
you're saying?
Those will get fire caught in the installation process.
What are you using for your attic access?
Good question.
Right now we're looking at a system that's called a vacuum sealed attic hatch door. We're still trying to get the specs on that, but that's one option we're looking for there. It actually has about R65 built in, R60, R65 as insulation and it's airtight vacuum sealed compressed fitting.
So there are a couple things that we had to deal with the building official in designing the passive house. That was one of them. We didn't want to put an attic hatch in at all. I shouldn't say that. We wanted to put an exterior attic hatch just in case maybe sometime you needed to get up there, and just make it a door. You put a ladder up and climb way the heck up there and get in. But
On the gable end.
on the gable end of the roof, above the insulation level. And he said, well, the code requires, and it's true, it does, it says it needs to be readily accessible from the inside. And I don't really know why, but I assume it's a fire safety thing. That if there's a fire up there, you can put it out. I'm not sure. Anyway, we had to put it in. So we battled back and forth, and he said, no, you got to do it. The other thing that was interesting was that he gave us a plan review note that said, you need ducted returns out of all your bedrooms for your mechanical system. It's like, well, there's no mechanical system except, well, we've got one sitting. You see where it says HVAC right there written on the wall, and you can see the line set coming in. So that's the second Mitsubishi mini split sitting there. So, so that was kind of funny when we got there. Were a couple others that were really specific. Do you remember?
Yeah, vapor barrier on the inside of the wall.
Oh yes, yeah. You want a vapor barrier on the inside of the wall. So we had to show them, just information from the Logix ICF. One of the good things about Logix is a block installer is they have all the details and all the testing, and there's a lot of good information.
Do you know the heat load? The heat load?
Yeah, the heat load in terms of how many BTU hours, 13,500 is the max. Yeah, and that comes straight out of the PHPP. So that's at the way PHPP calculates heat load is interesting. It looks at 2 scenarios. One, sort of a long string of cloudy days, which tend to be they use climate models, right? So we're looking at the Chicago climate models. The long string of gray days in this climate tends to be in the 20s, teens, it's snowing a lot, like for a week, and you're not getting a lot of solar gain. So it looks at that as a model. The other scenario, though, is it's super cold. It's 15 below. Well, those are those Arctic days when you get a ton of sunlight. So you can't, I don't think our climate history shows like 20 below or 15 below and cloudy. So it looks at those 2 scenarios and figures out what's the worst case and gives you that as your heat load. So these systems here, the rated capacity is 9,000 BTU hour each. So we're a little over, but that's their smallest unit. So it was a little too much to just have 1 unit and a little too much distribution. We talked to the Mitsubishi rep, who's an engineer, and he said, do 2 and you'll be really comfortably covered. At first we had the idea of putting some radiant heat in the floors, just like electric radiant mats in the bathroom floors, just turn on for a little bit and have a little supplemental heat, but we just scrapped it and said, forget it, we don't need it, so.
I'm showing your corner window.
Oh, yeah.
Cantilevered concrete.
Well, let me tell you a little bit about the layout up here. This is, the kids' rooms are the front one and this one. The kids' bath is over there. You're kind of clustered around the laundry room right there. And then this is a den family area. And this is all the master suite. So initially, in the early parts of design, I had a lot of corner windows going on. But ultimately realized that a lot of places where I'd put corner windows were looking into like the neighbor's garage and that sort of thing. So we eliminated it. So this one here, though, really opens up the master bedroom. We decided to keep it in. And Zola sent it to us in two pieces. They basically butted together and got sealed on site. And so therefore there's a fair amount of talk about what happened with the concrete and the forming.
Well, I mean, there's special rebar details, for the concrete header there, but basically it's a cantilevered concrete corner, no structural support in the corner from the windows or anything. So it was kind of cool.
Which the structural engineer goes, oh yeah, no problem. He's just like, I'll put some bars in there. And then Eric's going, are you sure? I was like, oh yeah, sure. That's not, Frank Lloyd Wright would have made that go like 10 more feet. I mean, we're tame here. So. Another interesting thing that came up in the PHP calculation. So we're doing this as a certified passive house, which means we need to send all our calcs and our designs and our specs and absolutely everything to PHAS, which is the Passive House Institute US. They're the training and certifying body. And PHAS, the Passive House Alliance, is the sort of outreach and education arm. So anyway, PHAS is certifying this. Graham, the guy who's our personal reviewer, is just absolutely honed in on all the details and is a master of this PHP software. And one of the things he said is like, it looks like your plumbing run calculation looks a little bit low. So when you're calculating the energy in the heating energy it's going to take and the primary energy that the whole building is going to take, you got to look at things like, okay, how many feet of domestic hot water do I have running in here? Because that's going to be using energy to heat up the water and putting that heat, depending on your R value that you're putting around your hot water pipes, dumping that into the house. So that's less that the mini split needs to run. And if you have 300 feet versus 75 feet of pipe, it's going to make a big difference in your calculation. A huge difference. I didn't realize. There were a couple things. I'd also put in too high of a number for the Zender efficiency. Oh, God. And it's a very efficient system. It's one of the highest. But I had put a wrong number in.
We've got more units.
Yeah?
We give you a higher number.
Okay. Well, let's talk. We'll talk afterwards. Because so all these things that you don't necessarily know until you've really run PHP a lot where it's going to hit you. But anyway, we had way under-calculated the pipe, just as he said. I think we had like a placeholder number in there, and then we went through and calculated each line. And the thing is, these sort of houses on narrow lots tend to get spread out, right? So, I mean, we sort of have the plumbing stuck together here, but as much as we could, but still, the master bath is way back there. And yeah, we could have put the master closet on the back wall and not had windows in the bathroom looking out, but design-wise, we didn't want to go with that. So what we found was that there's a lot of pipe, and it really lowered our heat load, but it upped our primary energy because we're using more energy to heat water, lose it into the house in the wintertime. So that was a bit of a surprise. So basically, in an ideal passive house, it's a really compact shape. It's got great south orientation. It's got the plumbing all kind of joined together close, and it doesn't have too many crazy air tightness details.
Are you upping the pipe insulation?
Well, we left that number alone. We didn't need to up it, but it's already like an R8. So, yeah.
What about putting an instant heater?
We could, but the thing is, we talked about that, and there was a difference in price, and we have a tank downstairs, which is our solar thermal storage tank, and then that just goes to a simple electric heater to add what little bit of heat needs to go into the domestic hot water. So, but we did go through that as a question. It's a good question. Yeah. Yeah, we're putting in. That's going to get filled up with a blown-in bat fiberglass. Well, yeah, I mean, amount of insulation we have in the walls is just going to keep whatever heat we have that we're losing inside the house. But what you see is that it takes away from the energy that you have to use for your mechanical heat, but it adds to whatever you're doing for your water heat. You follow? You are delivering warmth. But you could heat this house entirely with incandescent bulbs. But that would be a really inefficient way to do it, and your primary energy would go through the roof. You could also heat this house really easily with this number of people. In fact, in the wintertime, we'd be, you notice how warm it's getting in here? It's yeah, that's right, just about. Okay, so why don't we go downstairs and hear from Barry and company about Zender.